Displacement time graphs. Today we are discussing ST graph basics, displacement time graph basics. Gradient of a ST graph equals velocity. Actually, the gradient means the slope. Look at this. There's a constant gradient in this graph. That means velocity is constant. So, what about this graph? In this graph also gradient is constant or the slope is constant, that means velocity is constant. Now if you comparing this red line and black line, the gradient of the red line or the steepness is much greater, therefore this having a higher velocity compared with the black line. Now consider graph like this. What happens to the gradient? Gradient gradually keeps increasing. Look at this angle. Actually, gradient is the angle that makes with the x-axis. Here, tiny angle increased and this is more increased. That means gradient very clearly increases. So that means this is acceleration. Look at another shape. What about this shape? In this graph, initially there is a higher gradient, but gradually actually gradient is the angle. This angle keeps decreasing. So this is a decelerated motion. This is deceleration. In both these cases, gradient is constant, so it's a constant velocity, but in this red one, higher gradient, that means higher velocity. The black one is a lower velocity. Shall we consider another graph? What about such a shape? Initially, the slope is more steeper and here also the angle with the horizontal gradually decreases, and at the end actually no angle with the horizontal. So at the end this region it's stopped and down decelerates and stops. Let's consider an example. Now you imagine this AB two positions. If you run from A to B at a constant speed, and you wait at B for few seconds and returns back towards A at a higher constant speed. How to represent this in the ST graph? Initially from A to B running at a constant speed. So shall we draw it like this? We assume this is 30 meters, run at 10 seconds time, and you wait another 15 seconds. So this will be 25, and running back at a higher constant velocity. That means this line should be steeper. Shall we get this reading as 31? Now, how to calculate initial speed? So this is O, P, Q, R. Speed from O to P. You know, gradient of ST graph equals velocity. So if you get the gradient equals this y difference divided by x difference. Therefore, velocity equals 30. This is the y difference, x difference 10. It's 3 meters per second. And on its way back, speed is much higher. Therefore, velocity on return, displacement 30. The time taken in this from 25 to 31 only 6 seconds. So it's 5 meters per second. So this is constant velocity in this region, flat line at rest. Here again, constant velocity. Shall we consider another example? This is another ST graph. Initially, sorry, it's like this, then more steeper line, then again a flat line, then it's like this, then a straight line back. Shall we label this O, A, B, C, D, E? O to A, what kind of motion is this? O to A. OA, constant velocity, because gradient is constant. This is just a straight line. And A to B, this is also constant velocity, because but this is more steeper. Now look at this angle, it's that, but this angle to the horizontal, it's much greater. Therefore, AB must be higher constant velocity. And BC is a flat line. Therefore, this is at rest. Then in CD, what's happening here? It's curving up. So gradient gradually increases, or it's become steeper at the end. So CD, it's accelerating. And what about DE? Finally returns back to the original position at a constant velocity, but this is more steeper line. This is also higher constant velocity. Actually, this velocity is much higher than AB because it seems more steeper. Again, look at straight line, constant slope or constant gradient, therefore constant velocity. Again, straight line with more steeper straight line, so gradient is much greater, that means higher constant velocity. Flat line at rest, this line getting steeper with the time, that means obviously gradient increases with the time, so it's accelerating. And finally, straight line back to the original position, that means again a higher constant velocity.